Look at the sheer, overwhelming scale of modern AI training. Millions of computers processing endless oceans of human data. This process is built on something called supervised fine-tuning. To teach an AI anything, you have to feed it millions of meticulously crafted examples created by real people. To solve a complex math equation or write a piece of software, a human expert must write out the perfect step-by-step logic first, so the algorithm can mimic it. Human reasoning is slow, expensive, and finite. We can only write so many perfect examples, and that creates a hard ceiling on how intelligent these systems can actually become. Researchers at DeepSeek decided to strip away those human examples completely. They wanted to test if a raw, untrained model could figure out highly complex problems with zero supervised instruction. To build truly advanced intelligence, the industry has to stop spoon-feeding algorithms the exact steps of how to think, and instead simply incentivize them to find the correct answers on their own. They placed a blank slate AI model into a pure reinforcement learning environment. No guides, no human data, just an algorithm. The environment operated on a reward system with two incredibly simple rules. The model only scored points for generating the mathematically accurate answer and for placing its thinking process between specific formatting tags. The researchers remained completely hands-off. They acted strictly as a final judge to verify the math, providing absolutely no templates or hints on the steps needed to get there. This chart plots training steps against response length. As training progressed, the model autonomously spent more time contemplating problems. It learned to leverage extended test time computation, expanding its internal thought process from a few hundred words to thousands of tokens. The AI figured out extended contemplation completely on its own, proving that deep focus can be incentivized rather than explicitly programmed. As the mathematical constraints became increasingly difficult, those massive blocks of generated text revealed some fascinating internal behaviors. The model spontaneously developed advanced reasoning tactics. It learned to double-check its work, recognize logical dead ends, and automatically backtrack to try again. Look at this text log showing an intermediate version of the model working through a complex calculation. Mid-sentence, it stops, identifies a flaw in its own logic, and pivots to a new strategy. A moment of self-correction that wasn't programmed into its code. While this version, called DeepSeek R10, was a brilliant reasoner, its unguided evolution made it highly erratic. The output was often completely unreadable, blending bizarre formatting and randomly mixing multiple languages into a single sentence. To fix this, the researchers applied a small amount of human-generated cold start data. This didn't teach the model how to solve the math, but it established basic formatting and manners before running the reinforcement learning loop a second time. Human formatting established the boundaries, and pure reinforcement learning built the logic. That two-step pipeline ultimately birthed the final, polished DeepSeek R1 reasoning engine. This approach works. On the AME 2024 math benchmark, R1 scored 79.8%, and it hit 97.3% on the Math 500 test, results that place it side by side with OpenAI's O1 model. But the team's most lasting discovery was a process called distillation. This diagram shows how it works. Once the massive R1 model discovered these elite reasoning patterns, researchers were able to take those exact patterns and successfully transfer them into much smaller, highly efficient AI models. A distilled model with only 32 billion parameters, a fraction of the size of the giants, can now achieve a 72.6% on the AIM benchmark, outperforming much larger proprietary systems. The weights for these models are now public, allowing anyone to run advanced reasoning on a single household GPU. Scaling AI intelligence has shifted from a race for more human data to a focus on providing algorithms the autonomy and the computational time to think for themselves.